In this short video, I'm going to talk about erasure coding, take a very high-level look at how it works, and talk about why it's become so popular. Storage systems have become large, multiple petabytes, and traditionally we protected our data with RAID volumes storing multiple copies of files in multiple locations. With multi-petabyte systems, having 300 or 400% overhead to protect your data has just become too expensive. And that's where erasure coding comes in. Now, most object storage systems use erasure codes in one form or another. When a file comes into the object storage system, it isn't stored as a single file. It goes through an encoding function, and the result of that encoding function is several object parts. These object parts are similar to RAID in that there is both data and parity involved, but it's happening at the object or file level rather than the volume level. And underneath the covers, an object storage system has a distributed file system, and the object parts are distributed to that file system. So what happens if we want our file back? Well, we send a request for our file, and a subset of these object parts go through a decoding function, and the result of that decoding function is your original file. Now I want to introduce some ActiveScale specific terminology. Bit spread. This is an intelligent data placement approach that puts the object parts in the most ideal location to minimize the impact of hardware failure. And there is a video on our website about bit spread, how it works, and how it differentiates from other data placement approaches, so I recommend you take a look at that. Durability policies. In this case, the file that came in was encoded into 15 parts. So we have a durability policy in this example of 15.5. That means of the 15 parts, we can reconstruct the original file using any 10 of the 15 parts. And a note on durability, the more parts you have, the wider they can be distributed, therefore resulting in higher durability. So let's take a look at durability. Let's say we lose a component. In this case, we lose a drive. Well, we only need 10 parts to reconstruct our original file. In this case, we could lose 5 of our 15 parts and still reconstruct the file. What about a node failure? With bit spread, these parts are distributed in such a way that even with a node failure, we still have enough parts to reconstruct the original file. And what about something even more catastrophic, like a site failure? Well, with ActiveScale, you can lose an entire site plus more and still have access to all the parts you need to reconstruct the file. We call this a fail-in-place system, because even with multiple hardware failures, the data is placed in such a way that you still have access to enough parts to reconstruct the original file. Hardware failures in a fail-in-place system is not an urgent matter. With dozens of nodes and thousands of disks, when you lose a disk, a small fraction of the objects lost one part. Well, they're still well protected because there's enough redundancy built in. You can lose several parts and still recover the original files. So the takeaways from this short video is data protection based on multiple copies has become just too expensive. With erasure coding, you get a higher level of durability with a single copy of your data. And that erasure encoded copy can span and be accessible from multiple locations. For more information on ActiveScale and its implementation of erasure codes, visit our website.